So welcome back again to International Conference on Climate Change. So we will have another technical session right from now. So just let me introduce the session chair and co-chair. So this session will be chaired by Professor Sujit Kumar Devrama from Bangabandhu Sheikh Mujibur Rahman Maritime University, Dhaka, Bangladesh, and co-chaired by Dr. Mohammad Najmul Hassan from Department of Meteorology, University of Dhaka. So with that, I just leave to both honorable chair and co-chair to conduct the session. Over to you, sir.
Before 4B. ইকবাল সাহেবটা এখানে দিছ। Good afternoon. Am I audible?
Sir, yes, sir, you are perfectly audible.
Okay, I'm seeing Kamrul Hassan also. Kamrul, do you hear me? If I'm audible, then we can start this session. In this session, we have 7 papers, research papers, mostly young. All presenters are young, excepting one. It is swapped actually, Professor Iqbal from Australia. And our second presenter was Taslim Sultana and Professor Iqbal is swapped. So first presentation would be presented by Musammat Yasmin Akhtar. Our paper title is Projection and Evaluation of Extreme Temperatures Across Bangladesh Using CMIP 6 Multimodels. She is from Department of Disaster Management, Begum Rokeya University, Rangpur, Bangladesh. So may I ask Musammat Yasmin Akhtar to deliver her lecture. Musammat Yasmin Akhtar, do you hear me? The next presenter, Professor Mohammad Iqbal from Royal Meteorological University of Technology, Australia. His title of the paper is Designing an Effective Flood Forecasting Model for South Asian Floodplains with a particular emphasis on Bangladesh. The third paper is by Mehdi Hassan et al. The title of the paper is Developing an Integrated Coastal Vulnerability Index, ICVI, for the South Central and Southwestern coastal districts of Bangladesh. And he's from Department of Oceanography, University of Chittagong. The fourth paper will be presented by Alvi bin Hanan. The title of the paper is Assessing the Efficacy of Quantile Mapping as a Bias Correction Method for Remotely Sensed Precipitation Products over Bangladesh. Alvi is from Department of Water Resources Engineering, Bangladesh University of Engineering and Technology. The fifth paper is by Saida Tasnim Binte Haidar. Our title of the paper is Evaluation of Bias Correction Techniques for Precipitation, a Case Study for Agrological Zone of Bangladesh. And she's from National Oceanographic and Maritime Institute, NOAMI. The sixth paper would be presented by Ishrar Tahmin Anika from University of Dhaka. Our paper's title is Use of Geographic Information System, GIS, and Remote Sensing in Flood Management. And the last but not least, The paper title is Effects of Climate Changes on Ocean Acidification in the Bay of Bengal. It would be presented by MD Amit Hassan from Bangabandhu Sheikh Mujibur Rahman Maritime University, BSMRMU. So these 7 papers will be presented in this session. The first one is going to be presented by Musammat Yasmin Akhtar. May I call the attention of Musammat Yasmin Akhtar from Begum Rokeya University. She's not online. Online কিন্তু দেখা যাচ্ছে টোটাল নট ইয়েট, তাহলে আমরা সেকেন্ডটাই চলে যাই। হ্যাঁ, কিন্তু ইকবাল সাহেবের এখন হঠাৎ করে দিলে উনি কি এখন রেডি আছেন? Let us see. Is Professor Iqbal available online? Then we can go for the third one. Mehdi Hassan is online. So we are going to the third presentation. Mehdi Hassan would present on developing an integrated coastal vulnerability index (ICVI) for the South Central and Southwestern coastal districts of Bangladesh from Department of Oceanography, University of Chittagong. Mehdi Hassan.
Thank you, sir. May I share my screen?
Yes, yes.
Thank you.
And you have 15 minutes.
Okay, sir.
সাথে সাথে নেব না পরে, তখন তো টাইম হিসাব করা মুশকিল হয়ে যাবে। ইয়ে দিছো টাইমার?
Thank you very much for giving me the opportunity to present our work. My screen is visible, sir?
Pardon?
My screen is visible?
Yeah.
Thank you, sir. Thank you again for giving me the opportunity to present our research work. My supervisor was for this work was Dr. Muslimuddin Monna, Associate Professor and Chairman of Department of Oceanography, University of Chittagong, and Abu Sharif Mahabubi Kibriya from Bangladesh Oceanography Research Institute, and Dr. Mohan Kumar Das from Noami. My research topics is developing an integrated coastal vulnerability index for the South Central and Southwestern coastal districts of Bangladesh. First of all, I want to focus on the coastal vulnerability. As we know, coastal vulnerability is a special concept that identifies people and places that are susceptible to disturbances resulting from coastal hazards. As we all know that Bangladesh is the largest delta of the world, and geographically it is a low-lying country, and it has a long history of experiencing devastating and severe calamities. And that's why Bangladesh is considered as one of the vulnerable countries of the world. Sorry, sir. The coast of Bangladesh is a suitable test bed for evaluating coastal vulnerability, complex land use systems, and climatic conditions. In Bangladesh, previously, there have been many comparative studies in which researchers attempt to assess the vulnerability of different locations of coastal Bangladesh, but we see that there are some lackings. There are some lackings, and No integrated research was focusing on coastal vulnerability from the southwestern and south coastal regions of Bangladesh. At the same time, considering both of the social and physical parameters is crucial to understand the susceptibility of a coastal region. That's why we determined to take the opportunity of developing an integrated coastal vulnerability index, considering total of 12 socio-physical parameters for this area. And here is my study area. We considered the south central and southwestern coastal regions of Bangladesh, which covers 17 coastal districts out of 19 coastal districts of Bangladesh. Here is my objectives. Our main objectives is to develop an integrated coastal boundary index for the selected study area, and based on the ICBI results, to identify the degree of spatial vulnerability on the basis of socio-physical variables used in the studies. At the same time, we want to help the policymakers and administrators in generating mitigation plans and attaining the sustainable use of coastal resources. Those will also aid in prioritizing development projects and making decision for integrated coastal zone management. This is the flowchart of my working methodology. We considered 8 physical parameters and 4 social parameters. Among the physical parameters, we considered elevation, slope, sea level rise, storm surge, rainfall, wind speed, soil salinity, and soil permeability. On the other hand, for social parameters, we considered land use, land cover change, population density, literacy rate, and housing structure. Here is the data collection sources, as we use so many variables for coastal vulnerability assessment, and secondary data was collected from various sources. Here you can see that. And for data analysis, we use the square root of product mean proposed by Gornish et al. Here is the physical vulnerability index assessment equation and social vulnerability assessment equation. And after calculating the physical vulnerability index and social vulnerability index, we incorporated two indexes to get an integrated coastal vulnerability index following this equation. Here is the ranking ranges for different parameters used in this study. First of all, after processing the data, we used the IDW technique, and after that, we applied reclassification technique using natural break method in ArcGIS software for ranging, classifying the coastal zones into 5 classes. First one is coastal elevation. We used for coastal elevation, we used USGS, SRTM data set, and here we can see that the elevation of different areas of the study area, and here we can see the degrees of vulnerability for on the basis of coastal elevation. We know that coastal elevation is an important factor. Where the elevation is low, it is more susceptibility to coastal erosion or risks. Then coastal slope, and it is also produced from SRTM database.
Jasmine. Here
is the average annual rainfall. It was we prepared this average annual rainfall map using the BMD data, and where we can see that the southeastern region, which is basically Feni and Noakhali districts is highly vulnerable for annual rainfall. After that, we can discuss on storm surge heights. We also use the historical cyclonic records, which is collected from BMD and JTWC. After RTW result, we can show that the Hathi Island, basically, which is a part of Noakhali, is highly very vulnerable due to storm surge heights. Then rate of sea level rise. It was basically collected from secondary data, which was generated by Islam et al. In 2016. Here we can try to represent the vulnerable areas due to sea level rise. If we focus on the map, we can show that see that the Potakhali region is highly vulnerable for sea level rise. Then soil salinity. Soil salinity data was collected from SRDI. Can you hear me, sir?
Yeah, okay, go on. But make a haste, no? Make haste so that you can finish it in time. Plus, at the end of your presentation, there would be question and answer session. That's why I think better should be finished by within 12 minutes.
Okay, sir. Thank you, sir. From the soil salinity results, we can see that southern part, and basically the southwestern part, is highly vulnerable for soil salinity due to seawater intrusion in this region. And then is the soil permeability. Soil permeability is an important factor because higher the soil permeability, it's influence the coastal erosion or contribute in coastal erosion. And here you can see that due to soil permeability, very less area of my study area is highly vulnerable, and maximum area or majority area of coastal area is low vulnerable due to soil permeability. Then wind speed. Here we used wind speed as a proxy of wave action, because had the wave action and then here will be the erosion rate in the coastal areas. Here we can see that and here you can see that due to wind speed, the southwestern part, basically the Meghna estuary region, is highly vulnerable for wind speed. Then we considered for social parameters. First one is population density, and the population density data was collected from Bangladesh Bureau of Statistics. Here we can see that for population density, the Feni district and Chapur districts is highly vulnerable, because here the population density is comparatively higher than the other regions. On the other hand, in the southwestern districts like Potuakhali, Khonla, the vulnerability is less for population density, because we know that in this region the world's largest mangrove forest, the Sundarban, is situated here. So the population density is people activities are relatively less in this region. That's why it is low vulnerable. Then literacy rate. It was also collected from Bangladesh Bureau of Statistics. We can see that higher the literacy rate, the lower the vulnerability. In this case, from our study result, we can see that the Bhola district, here we can see that in Bhola district, the literacy rate is very low. That's why in this area is more vulnerable due to literacy rate. Then land is land cover. It was collected from the East Rift Global Land Cover Database, and it was also validated for overall ecosystem, which was almost 85%. And from the land cover result, we can see that few areas are which is denoted as or remarked as red color. Here you can see in this map is very vulnerable due to land cover change. On the other hand, if we see about the southwestern region.
Media sir, listen to me.
Yes, sir.
Already 14 minutes gone.
Okay,
So
sir.
finish it within 30 seconds.
Okay, sir. Now I am focusing on the physical vulnerability index. From physical vulnerability index, we found that Hatia Island, southern part of Bhola and Potahali is highly vulnerable, and where the Joshua, Narayan, Satkhira, and Khulna, Bagherhat districts are very low vulnerable. Then social vulnerable in this case, social vulnerability index in this case, Bhola, Shoretpur, and Lakshmipur districts are very high vulnerable, and Satkhira and Khulna is very low vulnerable. Finally, we got the integrated coastal vulnerability index, where we can see that the southeastern region, mainly in the Meghna estuarine region, which is covered by Borgona, Potokhali, Noakhali, Bhola, Satkhira, and some parts of Borishal, Jalghati, and Feni, is highly vulnerable for the socio-physical parameters we have studied. On the other hand, the western region, like Satkhira, Khulna, Bagherhat districts is less vulnerable. This is our major findings. Our major findings is that a large portion of Borgora, Potokhali, Noakhali, Bhola, Satkhira districts and some parts of Borishal, Jalghati, and Feni districts are highly vulnerable, which covers 28% of our total study area. On the other hand, as we said earlier, the western region is comparatively low vulnerable. Here is some recommendations for future researchers. We have faced some problem during the data collection. As you can see that for coastal vulnerability index assessment, a lot of parameters are needed, and some parameters, very recent parameters are not available, or their data quality is not up to mark. So we have to focus on this very recent data for a better vulnerability index. Alongside the method we have used in the study, we can also compare with the analytical hierarchy process or fuzzy logic gate based technique to find out the best fit method for our study area. Thank you, sir.
Now the floor is open for question and answer. I will invite only 2 questions from the audience. Is there any? Is there any person to ask question to the presenter?
Yeah, I'm Dr. Tyagi here. Good afternoon, Professor Dev Sharma.
Yep.
Okay, I just want to check up what is the resolution of this vulnerability mapping. Is it a district level or it is a sub-taluk or the village level vulnerability assessment?
Sorry, sir, can you?
Mediation, you have done a very good study. Congratulations. I
Thank you,
just
sir.
wanted to check up uh, whether this vulnerability is done at the district level or the taluka level or village level.
Yes, sir. We during the literature review, previously already have some works in different parts of coastal region of Bangladesh, and they have used some different tactics and variables, and basically those are grid-based. They used the grid-based technique for their area of interest, but the work we have done, this type of work covering the whole coastal region of this kind is very limited. So we attempt to take the chance to create an integrated coastal boundary index for this region.
Yeah, okay. Actually, he was interested to know about the resolution. How many kilometers or how many meters? That was the question. And if you can say,
Just,
if you
sir,
can
just
say,
once, sir, to 20 seconds. It is, sir, up to the Upazila level, not the district level, just up to the Upazila level. Maybe it is asked to which level you vulnerability are considered. Yes, sir. Thank you, sir.
Yes, sir.
okay. Maybe.
Thank you, sir.
Any other question? If no question, then we can go to the second presenter. We have in our midst Professor Dr. Mohammad Iqbal from Royal Melbourne University of Technology, Australia. He's an eminent professor. Earlier, he was with the University of Dhaka. And we'll hear from him about the designing an effective flood forecasting model for South Asian floodplains with a particular emphasis on Bangladesh. So, Professor Dr. Mohammad Iqbal, please go on. Important points too. And sir, you have 15 minutes.
Good afternoon. I am delighted to present my paper here on this occasion of the conference on climatic change on Department of Meteorology, University of Dhaka. And I have come from Melbourne to visit Bangladesh as well as present a paper on this occasion. So it's a good opportunity to see and to meet the people here and look through the works and their developments in the areas of meteorological activities and meteorological studies and such things. First, you can see the title of the paper, and if you concentrate on the title, you can see 1 to 3 important factors, actually factors in the title, which is, first is the designing of a flood forecasting model, but with a word before it goes, and it signifies the importance of designing is the word effective. It means still there are flood forecasting models at the moment active and being used in Bangladeshi flood forecasting purposes, but the effectiveness of such models are in questions in terms of their levels of implications and the significance of the results they are producing. And therefore, I have used the word effective. It was then. If you look at the abstract of the paper, it shows what were the factors that have inspired me to write this article and what result we can expect from this paper. We see the South Asian nations, including Bangladesh, operate a conventional and traditional flood forecasting system that seems inefficient and incompatible in handling today's challenging climatic and environmental circumstances implied in flood disasters under influence of global climatic changes. A timely and effective flood forecast about water level or abnormal large discharge that threatens safety of structures and floodplain activities is necessary in this age of global climatic change. An advanced warning of this stature helps authorities adopt a series of measures to minimize adverse impacts of flood on lives and economy. Unlike several other disasters, approaching flood can be forecast ahead of its occurrence with advanced collection of hydrometeorological data and its transformation into flood water level or flood hydrograph. However, selection of a particular method or model and its accuracy for a given site is largely governed by three factors: data availability, forecasters' knowledge and experience with the basin or catchment area, and importantly, forecasters' familiarity with the software that is to be used in the forecasting process. In this paper, efforts have been given to develop a theoretical framework to be used in designing a plausible and effective flood forecasting model that can be applied in South Asian watersheds, including Bangladesh. The approach is relied and based mainly on local hydrometeorological and topographical data, and also physical and cultural environmental perspectives. Nonetheless, we should remember that Bangladesh is ranked 7th among the most climate vulnerable countries in the world, whereas its contribution to global warming is negligible. Only 0.36% of all greenhouse gas emissions. Then followed by, in the following, we will see what are the principal factors that contributing to flooding in South Asian lands. We have seen heavy rainfall, overflowing rivers, collapsed dams, snow melt. This is not applicable for Bangladesh, rather should go for high lands of Pakistan and India, and the climate change itself. The third one.
Next.
Yeah. And the next you can see the flood inundation map of Bangladesh and the flood vulnerable areas that are mostly concentrated within the main channels and locating in the central parts of Bangladesh. And in these images, you can see the impact of catastrophic flood in central South Pakistan in August 2022. I have taken this image just to show as an example of what climatic change can do to cause such an havoc in a very short notice of time, and without giving any concern or any sign to authorities and no way to give any advance warning to the people of the affected areas or the area under risk. The left image show the area of Pakistan in August 27, 1 year ahead of the catastrophic flood. And the following image, 1 year after, the day of occurrence of the flash flood in the same area. You show the difference of in the images, the flood effects and its colossal damage that it has caused on its way through to the ocean. The flood in Pakistan, it's a flash flood, was accompanied with intense heat wave for 4 to 5 days. And that was followed by an incessant and extremely heavy rainfall that continued for around 6 hours in the top northwestern sections of Pakistan and was amplified in its magnitude by the addition of snow melts that came down from the north, mixed with the rainwater and drained down the channel. And when it came downwards, when it came toward the middle of the land, where the slope was a little bit lesser, it was not that much steep, and it spread along its bank and overflowed the region, the crops, the settlements, man, livelihood, everything. Whatever it came on its way, it just carried down to the south and submerged the whole area. You can see in the image. And that was a very catastrophic flood in which around 2,500 people died. And the authorities, they were totally failure, and they did not have any chance to give any warning or any notice to the people of the affected area. And they just became stranded and helpless in the situation. So we have seen one example of flash flood that can be so much dangerous and devastating, and can left impact of an, say, sort of never-ending misery to the people of the affected areas. Moreover, flash flooding is determined not only by meteorological factors, but also by hydrological factors such as terrain slope, land use, vegetation, and soil types, soil moisture, and hydraulic processes. Hydraulic processes are related to the character of stream or river channels subject to flooding. Most flash flooding generally is caused by slow-moving thunderstorms repeatedly moving over the same area. This which we have seen in Sylhet flood, that thunderstorms, they repeatedly moved over the same area and added to the incessant rainfall of the spot that came under the effect of the thunderstorms, and the heavy rains from hurricanes and tropical storms. But the two main important elements in flash floods are rainfall intensity and its duration. So in this figure, in this image, you can see the flood of the century that hit the northeast Bangladesh in June 2022. And you see the vastness and the areas, huge areas that covered under the fire, under that devastating flood of 2022. And meteorologists have developed 3 basic types of forecasting techniques that are being used in South Asian countries. These are quantitative techniques, time series analysis and projection, and causal models. And in my paper, I will focus on number 3, the causal models, from which we can derive the actual models that can be used for the right for the area that is under threat of flash floods. Coupling of meteorological and hydrological data. This can be obtained from rain gauge data and radar data, and simulation of data combining total rainfall, air temperature, wind speed, and relative humidity. These are very important factors in the coupling of meteorological, hydrological data in order to develop models that can be used effectively for the high-risk areas. Now we come to the point, how to develop an effective flood forecasting model for the central and northeastern regions of Bangladesh. We should point out on three factors which are held responsible for the causation of horrible natural disasters that have been happened in the last 10 years. These are extreme rainfall, the monsoon, and thirdly, the mountain glaciers, which is applicable for Pakistan cases. Bangladeshi river channels are not affected by any mountain glaciers other than the Himalayan areas, the Nepal and the northern part of India.
Finish it in 2 minutes.
And the main objects for designing a flood forecasting model is to what necessary things we have to do in designing a flood forecasting model is to quantify potential flood risks, including flash floods, in smaller and larger towns than the countrysides with high spatial resolution. Secondly, assess the effectiveness of possible flood mitigation measures, which is applied or appropriate for those high-risk flood-prone areas of Bangladesh, and the construction of an effective operational regional flash flood warning system, with the emphasis on urban centers of high-risk areas. So now we come to the point, how can we develop an effective method to reliably predict highly transient flooding process, the effective method, the production of an effective methods. In this case, we use the following methods. Some of the commonly used methods by various forecasting stations include simple correlation based on stage discharge data, coaxial correlation based on stage discharge and rainfall data, and third, network model, where in the lateral flows from different subbasins are calculated using unit hydrograph. In developed nations such as Australia, a flood forecasting system commonly consists of at least two essential components. That is, a numerical weather prediction model to provide rainfall forecasts and a hydraulic model to predict the hydrological response. We are not now dealing with the mathematical representation because it takes some more time and space. So we are switching over to the next, which is the predicted climatic changes in Bangladesh in next 120 years. You see the first image here. It's the current Bangladesh situation. It has got a tropical monsoonal effects, the deep blue portion, and the image is so small. Yeah, and the light blue zone is the tropical savanna. Tropical savanna, which is a grassland with occasional trees with canopy that are dispersed over the land. And the green areas, the temperate dry winter with hot summer, with green coverage. That means Bangladeshi climate is gradually going to be changed in the course of time and taking the shape of savanna climate, and with it the elimination of its greeneries in future I think this is a present condition, and then in the next 70 years, the situation going to be more worse. How can you skip to the next figure? The original figure.
শুভ, এটা একটু ইয়ে হয়ে গেছে, জুম হয়ে গেছে।
Yes.
জুম হয়ে গেছে, ডাবল ক্লিক করতে সিঙ্গেলে চলে আসছে প্রেজেন্টেশনে।
So the right image, you can see only two colors are dominating, the deep and the light blues. That means the greeneries are already eliminated by this time. I mean, this time is in the next 70 years. The Bangladeshi climate will be determined by the monsoonal effects and with the dominance of the savanna type climate, and the greeneries are already gone by that time in the next 70 years. And this is about an important aspect of designing an effective flood forecasting model. The changes in land cover of Bangladesh. Here we see the most of the land of this country, Bangladesh, is covered with agricultural lands with grassland in the middle, and the red ones are the long extended settlements and the forested areas. Here we see. This is the current situation of land cover of Bangladesh, and if we want to develop any effective flood forecasting model, we have to look at the land cover first, and this land cover is changeable. That we have seen in the previous figure image that due to changes in climatic conditions, the greeneries of Bangladesh are going to be extinct. I should say extinct in the next 70 years. And the dominance of savanna type of greeneries, I should not say that the greeneries, the savanna type of climate will dominate the most of the parts of Bangladesh. So what are the causal relationships in a flood forecasting model? We see a few things like flood forecast, the real-time forecast, highly active and active variables. These are climatic, physical, human, cultural interactions. Then preparation of flood maps and identifying flood risk areas, from where we can prepare the flood risk maps. And from that, we can generate flood warnings. And finally, we come to the point, the causal relationships in a flood forecasting model, which is very important. We see here the right-hand side elements. These are important ones: the air temperature, changes in relative humidity in watershed areas, rainfall data, and water level data. These are again related to the water velocity, related to soil property, then comes to the land cover, then water infiltration, and lastly, the human and cultural interactions, such as construction of dams, levees, and other infrastructures that influence the presence and causation of floods, both normal and flash floods. And you see here, these are the things where the meteorologist should take into the considerations about the relative shifts in isotherms, isobar, and isohydrates. These they should take into note. They will monitor these changes frequently and record the changes, the natural shifts, and that is going to be related to the monsoonal wind directions, changes in monsoonal wind directions and non-monsoonal wind directions. And these data need to be calibrated frequently. What happens? Now just conclusion. Yeah. So these are the elements, these are the factors, these are the causes. Meteorologists should concentrate on these points. And a few days back, I talked to the Department of Geography about the availability of these information statistics data on land cover, soil property, channel gradient, and channel water depth, water velocity. And the answer which disappointed me is that none of these areas have been sufficiently covered over the years. And this is an utmost important thing. If you want to develop a effective flood forecasting model, these data they should be ready and available whenever required to be added to the model and to predict the flood forecast and to generate flood warnings, etc. I think in course of time, this area should be given more importance and more works to be done on this aspect, especially on channel gradient, channel water depths, and water velocity measurement statistics data, and a detailed map on land cover of Bangladesh. And time to time, they need to be updated because on land cover, the rate of water infiltration is dependent. Therefore, you need to update most of the time.
Thank you so much, sir, for the nice presentation. Nice and enlightening. Due to time constraint, we are unable to give much more time, but it would be our pleasure to allocate more time to this great presentation. I'm sorry for interrupting. Now, I would like to request the audience to put only one question because we are running out of time. Only one question, if you have any, please. No question? I think there is no question. It is a very interesting paper, and actually it is related to our professional meteorologists and hydrologists to develop this sort of model actually. And Professor Iqbal presented this through his long experience. Really, these are the important factors which he discussed throughout his lecture. There is one thing missing out, that is actually cloud burst. In our area, we see before the onset of monsoon, due to cloud burst, that is very heavy rain within very short time. And that water just logs, that is water logging takes place due to not proper drainage system, and particularly in the hilly areas like our Chittagong, Cox's Bazar, and also in northeastern Sylhet region, and in many parts of India and Pakistan. Flash flood is just like that. So thank you so much, sir, for your nice presentation.
Yeah, for this.
So we can.
Okay, our next presenter, Mohammad Yasmin Akhtar, from Department of Disaster Management, Begum Rokeya University. The title of our presentation, Projection and Evaluation of Extreme Temperatures across Bangladesh using CMIP6 multi-models. So, Mohammad Yasmin Akhtar.
Assalamu alaikum, everyone. So can you see my slide?
Yeah, you are.
Thank you, sir. Assalamu alaikum, everyone. Heartfelt gratitude to Department of Meteorology, University of Dhaka, who organized an international conference on climate change 2022. Dear all participants and panelists, my own welcome. I am happy and lucky to join in this beautiful platform for this research goal. We know that this conference aims to bring together all leading academics, scientists, researchers, and researcher scholar to exchange and share their experience and research.
Yasmin, you have to finish it by 12, within 12 minutes.
Okay, sir. That's why today I am presenting projection and evaluation of extreme temperature across Bangladesh using CMIP6 multimodal. My name is Ms. Yasmin Akhtar, Department of Disaster Management, Begum Rokeya University, Rangpur. It gives me immense pleasure to express my deepest sense of gratitude and indebtedness from the core of my heart of my honorable supervisor, Dr. Abu Rezaindri Taufiqul Islam, Associate Professor, Department of Disaster Management, Begum Rokeya University, Rangpur. Here is my presentation outline. Now, the introduction of my presentation. Firstly, extreme temperature have devastating effect on both crop and animal productivity, evapotranspiration, and human thermal comfort and health generally. Then the temperature concentration is defined as the heterogenic behavior of temperature which can efficiently detect temperature extreme, and the observed climate change exhibit in the form of warming trend characteristic by longer and warmer summer, more frequent and severe heat waves, and a reduction in total rainfall, all of which are projected to persist throughout the 21st century. However, little knowledge is known from the earlier study about quantifying source and potential appointing a special pattern to project an increase in the frequency of hot days over Bangladesh as compared to the other part of the continent. Attribute to the region, first increase in the surface air temperature. Here is the literature gap. There are some literature gap find out in my previous study, such as Wang et al. 2070s. They does not identify the various long-term trend of the extreme temperature minimum and maximum. And then, according to Hussain et al. 2014, the annual and decadal variability of temperature extreme across the entire nation is not examined. And last one, Salvi et al. 2016, their analysis did not cover in this study, and thus provide an opportunity for future improvement. There is some problem statement. Number one, geographical location, then unpredictable weather, temperature, and extreme event, and there are many natural extreme events also. Here are some research question. First of all, what is the status of frequency and pattern of extreme temperature event over Bangladesh between 1995 and 2014, and examine forecast for two timeline, the near future, that means 2021 to 2060, and far future 2061 to 21st century. What will be the future scenario of extreme temperature event in Bangladesh? Then how do the temperature varies across the country? Then how do the 13 model of extreme temperature annual variation in Bangladesh relate to one another? And last one, in this area of Bangladesh that experience intense heat, how does the temperature fluctuate? Here is my objective of the study. This study aims to answer this issue by selecting Bangladesh as a study area. First one, to explore spatial and temporal changes in temperature extreme over Bangladesh. Then to analyze periodicity and distribution change in temperature extreme over Bangladesh. Last one, to quantify uncertainty in projected annual temperature or extreme over Bangladesh. Here is the study area. There are 22 graded data points all over Bangladesh. We know that there are 90 graded data are available, but I would like to take 22 graded data points because all are not appropriate and some missing data also. I have not using BMD data because this is not uniform. When I use station data such as agriculture station, climatological station, that's why I just use the data for a point scale such as with lat and long. But when I use the graded data, I can apply different meteorological station or meteorological data for a region. That's the area of the region is depend on the resolution of applied cost. That's why I use the graded data point. Here is the data source. The study used annual temperature data set of 22 graded data point across Bangladesh for the period of 1995 to 2040 and 2021 to 2021. Data are created by the graded source from Mr. ETL 2022 to 2020 and observation data are collected from BMD. Here is the data validation and quality control. We know that when the significance level of concentration at various lags less than 0.05, the data is qualityful. We see the figure, the data is qualityful, and all value are less than 0.05. Here is the definition of temperature indices which is used in this study, and there are eight extreme temperature indices used in this study. This index calculated in our climatic 2 in our studio. Here is the model dataset. There are 13 model used in this study. Here is the model dataset. Here is the scenario definition. There are two scenarios used in this study, SSP 245 and SSP 585. SSP means shared socio-economic pathway, and SSP 245 define middle of the road, that means medium challenges, mitigation and adaptation, and SSP 585 define fossil fuel development taking the highway, that means high challenge to mitigate, low challenge to adaptation. There is the method which I used in this study. Here is the overall methodology of the study. Here is the flowchart of overall methodology of this study. There are some software which I used in this study. These are. This is the most important part in this study result. Firstly, compare the model data and observed data. Now I am using in this study baseline period in 1995 to 2014. You can ask me why I can use in this baseline period, because firstly Mr. ETL 2020 and IPCC 2020 says this period are hottest than others, so I took this period. And this line plot of annual average delivers an overall outlook of the accuracy of the model. Here is the projected change. Here, this figure shows that the projected change in extreme temperature from multi-model ensemble mean CMIP6 GCM bias adjusted data during near 2021 to 2060 and relative to the baseline period 1995 to 2004 for the scenario SSP 245. Here the indices reflect the intensity TXS and TNN, frequency TX10P, TN10P and TX90P and TN90P, and duration GDD means growing degree, and WSDI means warm spell duration index. This the annual maximum temperature, that means TXS over the region exhibit pronounced warming toward the end of the century in both scenario. This region experienced an increase in TXS of 4 degree to 6 degree and TNN are 5 to 7 degree during near in SSP 245 scenario. Here 245 far future shows TXS 245 2 to 4 degree and TNN shows 5 to 7 degree mostly. Obviously under the SSP 585 scenario, a significant upsurge in TXS during near centuries projected over Bangladesh are 2 to 6 here 2 to 6 degree, and TNN shows that 6 to 10 degree, and far future shows TXS 4 to 8 degree and TNN shows 7 to 11 degree. Here the highest growing degree days and warm spell duration index in SSP 585 scenario. There are the GDD are 7 to 8 days and WSDI are 5 to 7 days. Here is the time series of projected extreme temperature anomalies, especially average over the study domain for the SSP 245, whose color are red, and SSP 585, whose color are blue. The black line shows the baseline period. All are highest higher than baseline period without TN 10P and TX 10P. Here is the projected trend analysis. This figure shows that the special trend of extreme temperature from the multi-model ensemble mean of CMIP6 GCM data for the near and far future relative to the baseline period. The analysis are based on the CMIP6 multi-model ensemble under the SSP 245 and 585. A summary of statistical trend analysis indices presented in this table, and this table table shows that all evident that a region experience a statistically significant increasing trend without TN 10P and TX 10P. That means this shows the negative value, and this shows the negative trend also. And and another value shows the higher than previous, that means baseline period. Here is the temporal changing behavior shows in this figure. This figure also shows that the increasing evident than past or baseline, and most affected year would become 2036 to 2060 and 2080 to 21st century. Here shows the uncertainty in projected annual temperature extreme. Analysis was carried out to characteristics the projected change in temperature extreme during the 21st century to examine the regional response in CMIP6 model under two scenario, that means SSP 245 and SSP 585. And projected change in various temperature indices shows noticeably clear change during the near and far future, and also under different scenario examined. However, TXS, that means TXS, then TXS and TNN and GDD and TX10 and TN10 are devastating change. Here is the periodicity of temperature extreme during near and far future relative to the baseline period. Periodicity of temperature extreme, the wavelet analysis is performed for the regional average indexes over Bangladesh to identify periodic pattern of temperature extreme. The wavelet power spectra of hot and cold indices are displayed. All these indices significant and are high, more than a previous decade. Here is the heat map of 7 climatic zone between two temperature index like GDD and WSDA, that means growing degree day and warm spell duration index. Here divided the 7 climatic zone of Bangladesh and identify the frequency individually, and this shows that the all the frequency are 4 to 6, and far future shows also far future also shows the 5 to 6, and near future shows the 4 to 5 days annually. After conclusion, I would say some limitation in this study. Total graded data are 90, but I have used 22 graded data point. Then total weather station of BMD are 34, but I have used 22. Total model data are 40, but I have used 13. And last one, total indices are 27, but I have used 8 models. And here is the conclusion or interesting finding also. There are TXS and TNN, that means extreme temperature, that means maximum temperature, and TNN means minimum temperature, depict strong warming over Bangladesh during the far future under the SSP 585 scenario. Then the projected change in the warmest night, TN 90P, will be stronger and more impactful as compared to the warmest day, TX 90P. Conversely, a sharp decline in cold days and cold night is projected to occur during mid-century and far future in both the SSP 245 and 585 scenario. Then TX10P and TN10P reveal statistically significant decreasing trend 5.07 per year and minus 3.59 per year in SSP 245 and far future minus 6.37 per year and minus 4.0.9 in SSP 585 near and far future over the study region in both time scale and scenario under consideration. Then the study projected an increase in minimal Tmax over Bangladesh by 1.79 degrees centigrade in near period and 2.30 degrees centigrade in the far for SSP 245 and 585 also. The mean annual Tmin projected to rise by 3.07 degrees centigrade in the near period, while 2.95 degrees centigrade in the far future for SSP 245 and 585 scenario. This study find out the significance of WSDI 6 days per decade and GDD 7 days per decade increasing in Bangladesh. Then increasing rate of temperature in northern region are generally greater than the other region at both annual scale, which may be relate to reduction in water storage and wetland. And last one, overall these results suggest that the region will experience a high increase in the intensity, duration, and frequency of hot extreme, while the cold extreme will generally decline over the entire study area. And this is the contribution of research. The researcher main contribution is that it is the first study in Bangladesh to demonstrate the evaluation of extreme temperature event using the CMIP6 multimodal and true scenario, which is significant implication for reducing natural disaster, agriculture output, and ecological preservation in the face of climate change. The result of this study will give a catastrophe professional and policymaker a roadmap that will assist them understand how contributing element affect Bangladesh temperature system and the sustainability of the trend line over time. This is the nobility of the study. First of all, this is the first work in Bangladesh while using the CMIP6 multimodal ensemble and use to scenario also. Then this is the first comprehensive study which is using the 13 model, the 13 global climate model, and it's also a long-term prediction which.
Ms. Yasmin, thank you so much for nice presentation. Due to time constraint, I think you have done well. Everything is okay. Now I would like to request the audience to place 2 questions, if there be any. Any question, please? Any question? One thing to note that at the end of the presentations, all presentations will have a little summary on all the presentations. So there is no question, so we can go for the next presentation by Alvi bin Hanan.
Thank you,
Assessing the efficacy of quantile mapping as a bias correction method for remotely sensed precipitation products over Bangladesh. Alvi bin Hanan, are you online?
Hello, yes, I'm online. I'm sharing my screen.
Yeah, okay, go on.
Right, I hope you can see my screen. So I'll begin. Right, so good noon, everyone. I'm Alvi bin Hanan, and today I'll be talking about the a study that we conducted recently, and it basically
Alvi, you have to finish it in 12 minutes.
Yes, right. I will try to, definitely. Right. So our study is titled Assessing the Efficacy of Quantile Mapping as a Bias Correction Method for Remotely Sensed Precipitation Products over Bangladesh. Here's a list of people that input their valuable intellectual inputs into the study. And so now, at first we'll talk about the objectives of our study. What did we try to find? So firstly, we attempted to produce a bias corrected data set for the CHIPS precipitation data that's validated against ground observations. Then we also tried to use quantile mapping as the bias correction method for this study. Then finally, we tried to assess the performance of the quantile mapping that we selected earlier in bias correction of the rainfall data set for different regions in Bangladesh, both during the pre-monsoon and the monsoon seasons. Right. So why was this study important? So firstly, we can definitely say that rainfall is a key component in the global water cycle, and it's essential for a wide range of applications such as crop modeling, hydrometeorology, water resource management, etc. So the accurate and consistent rainfall is definitely necessary for any sort of study, and the selection of CHIRPS dataset is significant because CHIRPS is a state-of-the-art satellite rainfall data that's characterized by its blending procedure using thermal infrared satellite observations using TRMM-based rainfall data, a monthly precipitation climatology, and atmospheric model rainfall fields from NOAA with ground-based rainfall measurements. So generally the problem regarding any sort of precipitation measurements is the measurements are based on rain gauge stations, meteorological radars, and satellite retrievals. So problem is that rainfall data from ground stations provide high accuracy, but they are limited to the spatial coverage. The meteorological radars suffer from reduced data quality owing to signal blockage. But the satellite data is a viable alternative, but they are generally prone to biases and say higher errors. So it's quite necessary to validate the rainfall estimates based on satellite observations against the rain gauge data of the observations in order to assess their uncertainties before we try to use them in any sort of study. So the algorithm that the method that we chose for this was non-empirical quantile mapping. So if for any sort of quantile mapping, what we generally do is attempt to map the cumulative distribution function of, say, satellite observed data onto the observed data set. So as we can see on the left, the equations are generally, equation shows a transformation of the satellite observed data, that transformation that's applied on satellite observed data to match the quantile observations. So what non-parametric empirical quantile mapping does is it attempts to solve the second equation, where it uses the empirical CDF of observed and model values instead of assuming parametric distributions. And these empirical CDFs are approximated using tables of empirical percentiles, and values in between the percentiles are approximated using linear interpolation. So about the study area was definitely Bangladesh, and we collected rainfall gauge station data all over Bangladesh for 31 stations. And for the satellite observations, we took the nearest value from the nearest grid coordinates of the satellites. So this brings us to a little bit of description about our satellite observed data. As I said earlier, we used the CHIRPS data set, and it was taken from the Climate Hazard Center from the University of California, Santa Barbara's data portal. The data format was gridded, and it was available in NetCDF format, and the spatial resolution was 0.25 degrees. And for keeping harmony in the study, we collected both the data over a period of 2011 to 2021. Right, this brings us to the methodology of our study. Here, at first, we collected the CHIRPS precipitation and BMD rainfall data, where we took and extracted the CHIRPS data and processed the BMD rainfall data and spread them to monsoon and pre-monsoon data sets. The monsoon data sets included months June, July, August, and September, and the pre-monsoon months were chosen as March, April, and May. Right. So then we performed quantile mapping and prepared a bias-corrected precipitation data set, which was then set for evaluating the performance. The parameter chosen for evaluating the performance was R-squared. So here is some of the results. These scatter plots show the observed and bias-corrected rainfall data set for a few selected stations that basically takes a note of different zones of Bangladesh. We can see here that the results in Chittagong are quite high, quite good compared to the other stations. And one more important thing to observe is the pre-monsoon seasons perform better the quantile mapping performs better for the pre-monsoon seasons as opposed to the monsoon seasons. And this is a bar chart showing all of the R-square values for observed and bias corrected data for all the stations that we performed our study on. And as we can see here, one station show a very bad correlation value, very bad R-square value, but the others show significant, show some sort of better values as opposed to other methods. And for one important thing to observe here as well is that the pre-monsoon season is almost better for all the stations almost for quantile mapping. So this can be explained by the fact that there are a lot of dry days in the pre-monsoon seasons in the months of March, April, and May, where the precipitation values are almost zero, and so we didn't do any filtering of the zero values. So this is why we probably have a higher R-square value. And this is a spatial plot showing the results, showing the R-square values for both monsoon season and the pre-monsoon season. The monsoon season on the left and the pre-monsoon on the right. Yeah. Okay. Now let's discuss a bit on what we found in our study. So the summary of our findings was quantile mapping does perform relatively well for bias correcting the rainfall data in the southeastern region of Bangladesh. As we can see in the previous plot here, the observation show the maps show that the values are quite good in the southeastern regions, and it's comparatively worse in the northwestern regions of Bangladesh. And overall, we can see that the pre-monsoon season performs better than the monsoon seasons, right? So these are the summary of our findings. So now we face some limitations during our study. The first was the obvious lack of harmony in the observed data. The observed data provided there was some inconsistency in the data set that required rigorous pre-processing. Then for the satellite data also, we couldn't access higher resolution gridded satellite data set, which we believe if we could include, it would definitely improve the performance of our study. Then a further suggestion on going on for future researchers would be if it is possible that the observed data can be collected at a higher temporal resolution, say even hourly, that would be great for the study. And one thing we are thinking of doing moving forward is we will try to create an ensemble data set that would include precipitation products from different say satellite sources and even reanalysis data sets like ERA5 and maybe Aphrodite and so forth, and try to use them to assess other methods of bias correction as well, and possibly machine learning or other sorts of processes. And for that, definitely we need higher volumes of data and at better resolution. Right. So this basically concludes our presentation, and so thank you very much for listening. And if you have any questions, I would be glad to answer.
I will. Thank you, Mr. Alvi bin Hannan, for nice presentation. Our next presentation, presenter Mohammad Shahadat Hussain of Noami. He will present the paper instead of Soyeda Tasnim Binte Haidar. Title of the presentation: Evaluation of Bias Correction Techniques for Precipitation, a case study for agroecological zone of Bangladesh. Mr. Mohammad Shahadat Hussain from Noami.
Assalamu alaikum and good afternoon, everyone. My name is MD Shahadat Hussain, and I'm doing my graduation from Department of Geography and Environment, Jahangir University. It's a great pleasure for me to join with professionals and resourceful person here, and I'm here today to present our study. Our study title is Evaluation of Bias Correction Techniques for Precipitation. a case study for agroecological zone of Bangladesh. And you can see here are the list of the authors who are involved in this study. And the next section is here are some contents which we're gonna discuss in our presentation. For the motivation of the study, we can say during the last few decades, natural hazard damage the natural and man-made environments significantly. Hydrological hazards are among the most destructive hazards, are increasing in frequency, magnitude, and intensity of extreme events. These hydrological extremes like storms, floods, hydrological droughts, etc., have always been a threat to human society. The projection of future climate with fidelity is of immense importance for supporting the impact and adaptation assessment and planning. The primary tools for such studies are climate models because they provide continuous spatial and temporal fields like temperature, wind, and precipitation are based on physical laws. Generally, general circulation models, GCM, are used to project the future climate. However, the impacts of climate change will differ more on regional and national scales. Due to this, there is a growing interest in regional climate change and its impacts, which demands a high-resolution description of climate. In the last decades, the RCM model, or regional climate model approach, has become a very popular for simulating regional climate for a limited area domain. However, the degree of agreement between the observed bias-corrected rainfall data may vary spatially and seasonally. The regional topography, elevation, and selection of regional climate models for the study also influence the results of correction methods. The next, we are gonna present of the objective of the study. In general, the objective of the study of the research is to assess the performance of different bias correction techniques over different agroecological zone of Bangladesh. If we say specific objectives of the research, then we have to say to review the bias pattern of precipitation over study area, and identify the bias varies which varies seasonally, and to investigate bias which is associated with land use or land cover and regional topography. And another objective is to review the performance of bias correction techniques in different agroecological zone of Bangladesh. This study will be conducted on the different agroecological zone of Bangladesh. Here you can see the study area map, Bangladesh. As the climatic condition in these regions varies, it is unlikely that one method applied to a region can be transferable to another region. So a range of bias correction techniques will be applied to each region. Due to some limitation and time constraints, we have worked only on the Sylhet region only, and but we will work on we will work later and analyze other zones also, and we will submit the whole agroecological zone in our full submission. The next slide is for data and methods. Here we used, you can see we used observational data and model data. For observational data, we used CMIP6 models for South Asian data, precipitation data, which is for the period of 2005 to 2014 for 10 years period. And the model data, which we used to validate the observational data. The model data we used it's Bangladesh Meteorological Department, BWD station data for 2005 to 2014. It's also a 10 years of period. And the method we applied, we used a significant, we tried to find out the significance using the Wilcox U-test, and also we will use some bias correction methods in our next analysis. Those are scaling, local intensity scaling, and empirical quantile mapping. And the next, we can see the results. Some results we have produced. This is the monthly bias assessment, which you can see that the June, July, August, these months are showing some higher bias assessment, and a few months also there we can see some model underestimate and overestimated in few months. So this is for monthly bias assessment. And another one, we tried to find out about pre-monsoon and monsoon season. In this graph, we can show, we can see that the bias assessment for pre-season, March, April, May, and monsoon season for June, July, August, September, and higher bias showing in the monsoon season. And the next slide, we can see that we used U-test. Before we tried to use the T-test, but it wasn't showing efficient result because of a small amount of data. But we will use T-test in all area or bigger data for all agroecological zone for Bangladesh. And using T-test, we find out significant bias found in February and April month. Here is the conclusion. For conclusion, we can say we found out some results that monthly were estimated and underestimated was observed for all the month, and monsoon months showed higher variability. Bias were higher for monsoon compared to pre-monsoon season, and the significance of bias for February and April months were significant. Thank you. That's all for the timing.
Thank you for your nice presentation. Sir, would you please ask the next presenter?
Now I would like to request Ishar Tahmin Anika to present her lecture on use of geographical information system and remote sensing in flood management. Ishar Tahmin Anika. Are you online?
Yes, sir. Am I audible, sir?
Yeah. Okay. Go on. Try to finish it in 10 minutes.
Okay, sir.
Go to the methodology, results, discussion, conclusion.
Okay, sir. Good afternoon, everyone. I am Ishar Tahmin Anika. I am honors final year Institute of Disaster Management and Vulnerability Studies, University of Dhaka. Now I will present the geographic information system, remote sensing use in flood management. Welcome to the presentation. We know that geographic information is the gathering, managing, and analyzing of data based on geographic information system, and the remote sensing is basically identifying and controlling the elemental qualities of any properties without any direct connection with that. And as we all know that disaster management have 4 phases, which is mitigation, preparedness, response, and recovery, where mitigation is focused on prevention and avoiding the future risk of flood, and preparedness is creating the awareness to limit the harmful effects, while response is focused on minimizing the losses due to the flood, and recovery is basically return damaged areas to the normal conditions. My study is based on secondary data. Now I will present how GIS and RS can be used in flood management. So at first we can see that in mitigation stage, flood hazard map can be created by satellite imagery collected by NOAA, and it is used to measure the flood frequency, depth, and land cover. Then it is stored with digital aviation data, geologic, physiographic, and drainage map, and through this way, hydraulic parameter is generated. From this, 2 types of flood hazard map can be created. One measuring the water depth, and another one is measuring flood frequency. And in FEMA work with local government and people with long and short-term plans. These plans have ultimate goals to increase education and awareness. Now, 87% people are living in areas where there is an approved mitigation plan. In next slide, we can see that in risk reduction activities, GIS can be used by assessing the flood risk from flood data. GIS has enabled the development of decision support systems before flood can turn into a destructive mode. Recently, an innovative decision support system for flood risk reduction has been developed by RMSI. Satellite images and GIS tools provide information about the rivers, dams, and lakes by showing 3D models and mapping. In this graph, we can see that the number of dams with respect to number of rivers in Southeastern Asia can be plotted by identifying it through GIS. In preparedness stage, flood management information system can be created. GIS can help to create a flood management information system. From primary data, flood peak is calculated, and then flood forecasting model and hydrologic models are created, which can be used to generate information. In securing the emergency response, in July 31, 2020, the water rising level of Jamuna River was monitored by FFWC and possible from the analysis captured by MODIS and NASA's Aqua satellite. Okay, it is very important to find disabled people who are not able to move promptly at the time of flood. And this evacuation plan, the map can be created by using GIS, and possible location can also be identified. Okay, in next slide, we can see that precipitation concentration index from GIS data. This index tells much about the flood condition or weather changing factors. Both MSS data and SAR data were used to map flood boundaries in Bangladesh. By mapping, we can find the vulnerability of agriculture dependent household. SAR imageries typically have a detection limit of 1,000 people per settlement. Near infrared range gives information about the water and soil moisture, while MSS band 7 range 0.8 to 1.1 displays water bodies correctly. Okay. Here we can see two image from Landsat 8 satellite data. Vegetation was greater than the next picture, so we can come to the decision that vegetation of this area are less affected than the other one, which was the picture of May 18, 2016, when Sri Lanka was affected by destructive flood due to heavy rain. Remote sensing helps to identify flood depth. Visible wavelength range indicates the color of water and its opacity. In flood water depth estimation tool, depth of water of every space within the flood affected area is computed altitude with respect to the height of closest flood boundary location. Remote sensing can also identify the drainage area from near infrared value 0.7 to 1.1 micrometer and mid infrared value 1.3 micrometer reflectance. And in this picture, we can see the GIS can assess the network and closest possible routes in an affected area. Like we can find nearest possible hospitals in a particular location through buffering technique. And lastly, in recovery stage, in water quality monitoring through remote sensing, coagulation of chlorophyll can be monitored by reflection rate. Satellite provide many Earth observation sensors and gravity recovery and climate experiment or GRACE tool for continuous assessment on diversified watery elements that plays an important role. Okay, Townsend invented a GIS technique to identify the index of deprivation. Positive Townsend index or relatively higher values suggest that people of that area widely deprived of those facilities. Theft and robbery are taking place and also helps in decision-making process according to resource allocation to prioritize the most vulnerable community. This is all of my presentation. Thank you everyone for listening.
Sir, please unmute yourself.
Sorry. Thank you, Ms. Anika, for your nice presentation on GIS and remote sensing method in the management of flood. And due to time constraint, we could not invite any question. Our last but not the least presentation on effects of climate changes on ocean acidification in the Bay of Bengal by Muhammad Amit Hassan from BSMRMU, Bangabandhu Sheikh Mujibur Rahman Maritime University. Amit Hassan, try to finish in 10 minutes.
Thank you, sir. This is Muhammad Amit Hassan from the Bangabandhu Sheikh Mujibur Rahman Maritime University, Bangladesh. And my topics of the oral presentation is effects of climate change and ocean acidification in the Bay of Bengal. My team member is our supervisor is Dr. Mohammad Kumar Das sir, Executive Director of NOAMI, and my colleague is Nausheen Alam, Naim Akhtar Nipu, Tasnuz Jahan Mim, and Maisha Salohak, who are the student of Bangabandhu Sheikh Mujibur Rahman Maritime University. The objectives of our study is to assess and predict the future ocean acidification, and to mitigate the ocean acidification. What is the parameter like as the river discharge, which mitigate the ocean acidification in the Bay of Bengal, and the relationship between the other parameters in the ocean and the pH, which affect the ocean acidification also. And because of ocean, the other objectives is the relationship between the solubility calcium carbonate and the self formation, which is affected by the ocean acidification. The term ocean acidification is the long-term decrease in pH in the ocean, which brought by the absorption of carbon dioxide from the atmosphere. We know that also. And there is many sources of ocean acidification, like as deforestation, industrialization, nuclear power plant, and which affect the atmosphere the most and the ocean also. The carbon sink from the atmosphere. The carbon sink from the atmosphere, which dissolve in the ocean, which decrease in the pH and affect the ocean acidification. The climate change is a threat of ocean acidification, like as because of anthropogenic carbon emission from many other sources, that it increase the temperature and this effect on climate because of increasing temperature, decrease in pH, and ocean become acidic, and it affect the marine life also. Our study location is in the entire Bay of Bengal by the satellite data. the global scenarios of ocean acidification, we can see that in the right top portion, the variation of pH in the Bay of Bengal and the surface aqueous partial pressure of carbon dioxide, we can see the pH in the Bay of Bengal is decreasing annually, but the partial pressure of carbon dioxide is increasing annually in the Bay of Bengal. The global state of ocean acidification see that the ocean pH is in the 1850 was basic, but it will decrease because of ocean acidification and become the ocean and the atmosphere acidic, acidic in the next century. Our study assessment of ocean acidification is to we measure the pH of the ocean in the Bay of Bengal study region, and it relate with the other parameters and identified the cause of ocean acidification in the Bay of Bengal, and we tried to mitigate the carbonate buffer system disorder by some study, and we may create a hypothesis and design our investigation using the satellite data. The parameters we studied: the sea surface temperature, pH, saturation state of aragonite, sound absorption, partial pressure of carbon dioxide, surface downward flux of carbon dioxide, dissolved in organic carbon, and alkalinity also. And the parameters related with ocean acidification, like as the sea surface temperature, which we can see a plot in the Bay of Bengal, the highest temperature in the deep sea, but the lowest in the coastal region of the Bangladesh in the Bay of Bengal, because of the river discharge and the other factors. Also, the temperature is decreased in the coastline, but it is increased in the highest in the deep sea. Because of temperature increase, it resulting in the ionization and formation of more H+ ions, and it decreases the pH, and it becomes the ocean acidic. You can see the 4 graphs, like in the top portion, the sea surface temperature in the left and right, the pH variation. We can see where the temperature is highest in the red color, like as in the deep sea, but the pH is the lowest. Yeah, so you can say that the temperature, because of temperature increase, the pH will decrease also. And there are other parameter is the saturation state of aragonite, which is a carbonate mineral, and it measures the carbonate ion concentration, which helps to measure the ocean acidification. There is the variation. See that in the deep sea, that pH is the lowest, but the saturation state of aragonite is the highest. In the left under portion graph, you can see that the saturation state of aragonite is decreasing annually, and the pH also decreasing. So because of the temperature is increasing, saturation state is if decrease, it affects on the marine life and other surroundings also. The aragonite saturation state of aragonite, if it becomes 3 or higher, it helps the marine life to become stable, and if it become less than 3, it stresses the marine life and the organism, and it also affects the coral reef, where because of this the coral reef become bleached. And if the saturation state become less than 1, the shell of other organism become dissolved and make the ocean acidified. The partial pressure of carbon dioxide is also another parameter of this study of ocean acidification. We can see that the partial pressure is the highest in the deep sea, but the lowest in the mid region, like as in the swatch of foreground region. And partial pressure of carbon dioxide also affects on the ocean acidification. We can see the temperature variation and the partial pressure. If the temperature is increasing annually with fluctuation, and the carbon dioxide partial pressure of carbon dioxide is increasing, which makes the more carbon dioxide in dissolved carbon dioxide in the Bay of Bengal and make pH decrease. The dissolved inorganic carbon is another parameter we studied. It is a biological pump which is different than biological produced organic carbon flux, which affects on the ocean acidification. We can see the global variation and the Bay of Bengal of the surface ocean dissolved inorganic carbon and the downward flux. We can see that where the inorganic carbon is the lowest, the downward flux is the highest. And it is because of this, the ocean is more acidic in the deep sea and than the surface ocean. The sound absorption is another parameter, which is interesting parameter. Like if the ocean become acidic because of temperature increase and the carbon dioxide increase, partial pressure of carbon dioxide increase, the ocean cannot absorb the low frequency sound more, and it affects on the oceanic environment because it makes the ocean noisy, and it's affect the marine mammals and other animals also. We can see that left portion, the frequency carbon, the sound absorption, which is a gradual change, and because of magnesium sulfate in pure water and the boric acid, and the light portion, the temperature variation. There is many much effect of ocean acidification, like as the food chain, decrease in storm, increase in the bioerosion, effects on commercial fishing, absorption, sound absorption, less coral bleaching, and the other marine species also. Yeah, there is no perfect solution of the ocean acidification, but we can mitigate the future ocean acidification by some policies or negotiation. Like the ocean firstly, we have to findings the issues in the Bangladesh of the Bay of Bengal of ocean acidification. Then we have to make the policy, like the implementation of projects in vulnerable region and long-term program to meet the climate challenges. The role of Bangladesh in the ocean acidification campaign, advocacy, and develop areas specific land. The negotiation like as with the international level, because of technology, fund structure, and joint research works and vertical integration also. If we want to mitigate the future ocean acidification, we have to make the collaboration with different countries for research work and monitoring variation in ocean chemistry, and enhance knowledge on the effect of ocean acidification and make hard work also. The future scheme for ocean acidification, we can see the established laboratory long-term plans have to work hard and limit the carbon emission by some process and the eco-friendly work. The conclusion of this study is to if the carbon dioxide emission become less, the ocean acidification will less. If global carbon dioxide emission are not controlled, the evidence suggests that ocean acidification is occurring now and will weekly continue regression. And the double difficulty of ocean acidification and climate change is possibly the most important environmental problem facing people today. Though the ocean is acidified less annually, like a 0.01 in decrease in pH, but it affects the environment of ocean and the atmosphere much. The recommendation of this study is a reliable network to observe, create a baseline, identify and forecast biochemical reaction caused by the acidity, and strengthen the capacity of scientists studying the ocean acidification, make awareness and more research work on it, and make sure that important maritime ecosystem and environmental services are monitored and governance policies. We want to acknowledge my colleagues and my supervisor, Dr. Mohan Kumar Das also, and Dhaka University Meteorological Department also. Thank you for give me the chance, and thank you to all.
Thank you, Amit Hassan, for your nice presentation and finishing on time. We are at the end of our session almost. And now we have maybe 2 to 3 minutes for question and answers on all the presentations, if the learned audience have any. May I request the learned audience to ask 1 or 2 questions. If not, we can.
I have a question, sir.
Okay, please.
My question is ocean acidification, a very beautiful presentation. There, is there any effect in the coastal zone of Bangladesh due to ocean acidification? And it is how it is measured, or it is yes, this is my question.
Thank you, sir.
Please,
Sir, ocean acidification, our study was done by the satellite data. We can see that the ocean acidification in the coastal region is decreased because of river discharge and other river discharge, and pH is not much decrease in the coastal region because of river discharge. It is the main parameter, and we study by the satellite data.
Thank you, Amit.
I have interest. I can contact with you regarding this issue. I have interest on this.
Thank you, sir. We are the student of third year, because that's why we can study much. Okay,
yes.
Sir.
Okay, thank you, Amit. Thank you, the questioner. And is there any other question? The floor is open to another person. If there be any question. I think there is no question.
Hello.
Oh, okay. If you have, okay, please.
Hello. Yeah, I have a question about prediction of extreme precipitation. Actually, maybe it was from Begum Roquea University. I didn't recall the name of that participant.
Which author?
Yes, please. Okay. It was a nice presentation, but I have a question regarding the climate models. Why do they pick those 13 models? What was the thinking behind it? Is that any ranking or something else?
I think, is it the question to Mosammat Yasmin Akhtar?
Yes.
Okay, is Yasmin Akhtar online?
Yes, sir.
Okay, please answer.
I have using in this 13 model because I have already said MISRA ETL 2020 they have used 13 model also, and they said this is the appropriate and their papers purpose or their their paper purpose, I think, and this is important for our country, and this is appropriate for our country. That's why I am using in this 13 model.
Okay, thank you. That means there was a reference paper. Maybe
Yes.
I didn't pick that. Thank you.
Yes,
Thank you
thank
very
you.
much.
Okay, thank you, the presenter and the questioner. Now I can request the audience to make one-to-one contact for inquiries or any questions they have. And now we're almost at the fag end of the session. At the very outset, I would like to thank the organizer of this international conference, particularly to the Professor Dr. Tawhida Rashid for inviting us to conduct this prestigious session. In this session, we had 7 presentations, excepting one. All are youngsters. So that is a very scintillating and exciting matter for Bangladesh, that our youngsters are coming up to take the lead to bring Bangladesh to new heights, which is the actually SDG of the government, and actually it is throughout the globe. Now, I'd like to summarize. That is in very short, in nutshell. The first presentation was projection and evaluation of extreme temperature across Bangladesh using CMIP 6, version 6 actually, multi-models by Mosammad Yasmin Akhtar. They used a bias-adjusted coupled model intercomparison project phase 6, 13 models to understand the future spatio-temporal changes and trends of extreme temperature in near future, that is 2021 to 2060, and far future 2061 to 2100 at the end of this century. Their results revealed a significant increasing trend in temperature in the near future and far future all over Bangladesh during a significant temperature year 2035 to 2100. The second presentation was by an eminent professor, Dr. Muhammad Iqbal, on designing an effective flood forecasting model for South Asian floodplains with a particular emphasis on Bangladesh, which is of interest to the professionals, I mean professional meteorologists and hydrologists of this region. And this was very, very interesting, of course. And only he was the senior most person, and all 6 others are our youngsters. Very encouraging, promising. The third presentation was developing an integrated coastal vulnerability index, ICVI, for the South Central and Southwestern coastal districts of Bangladesh. It was prepared by Mahdi Hassan, Muhammad Muslimuddin, Abu Sharif Muhammad, Mahbubi Kibriya, Mohan Kumar Das. And they attempted to develop an integrated coastal vulnerability index, ICVI, for the most dynamic and non-uniform South Central and Southwestern coastal districts of Bangladesh based on geospatial techniques using both conventional and remote sensing database. Their results showed that a large portion of Barguna, Patuakhali, Noakhali, Bhola, Shariatpur districts and some part of Borishal, Jhalokati and Feni districts are highly vulnerable, while western regions like Satkhira, Khulna, Bagerhat, Jashore and Norail has been identified as very low to low vulnerable districts in terms of physical and social vulnerability indices. The fourth one is assessing the efficacy of quantile mapping as a bias correction method for remotely sensed precipitation products over Bangladesh by Alvi bin Handan, Mohan Kumar Das, and Mohsen Al-Lopa, Arafat Ahmed Mridha, Tasfia Tasnim, Farooq Abdullah, and AKM Saiful Islam. They aimed to correct the bias for daily precipitation from the CHRPS version 2 datasets against existing station observed rainfall provided by Bangladesh Meteorological Department. Over a period of 2011 to 2021, they found that both the empirical quantiles, quant, and robust empirical quantiles, RQuant methods reduce the bias for the remotely sensed datasets by a considerable margin and perform better for northeastern region compared to other regions. Actually, these papers need some more attention and some more case studies to establish the hypothesis. The fifth one is evaluation of bias correction techniques for precipitation, a case study for agrological zone AEZ of Bangladesh by Saida Tasnim Binte Haidar, Mohan Kumar Das, Mohammad Mazazul Alam Sarkar, Rijia Khatun, and Mohammad Sadat Hossain. It was presented by Sadat Hossain. They attempted to evaluate the performance of different bias correction techniques over different agroecological zone AEZ in Bangladesh. The daily precipitation and monthly average data set from TIMIP are used for their analysis. They applied bias correction techniques, namely linear scaling, local intensity scaling, power transformation, gamma distribution, and quantile mapping. The performance of these bias correction techniques is assessed using several statistical measures. For varying topography and rainfall pattern in Bangladesh, there is a need for more region-specific information about the choice of correction methods and the simulation model that can help in policy and decision-making in agriculture and other related fields, other stakeholders. The sixth one is use of Geographic Information System, GIS, and remote sensing in flood management by Ishrar Tahmin Anika alone. Based on secondary data, she used both qualitative and quantitative methods. She utilized the tools ArcGIS and ADAS Imagine with a view to creating risk maps. Her findings show that flood hazard map can be used to evaluate flood risk as it can be ranked by flood affected frequency. However, there are some limitations that include cloud overcast and dense canopies, which need to be eliminated, because if there is overcast cloud and dense canopies, then the feature underneath on the ground is hidden. The last but not the least presentation is effects of climate changes on the acidification in the Bay of Bengal by Muhammad Amit Hassan, Naushin Alam, Naima Akhtar Nipu, Tasnur Jahan Mim. It is interesting that they are all my students at the University of Bangabandhu Sheikh Mujibur Rahman Maritime. And ocean acidification in conjunction with climate change greatly stresses marine animals spanning from tropical to high latitude environments. Their research looked at how climate change is affecting the acidification of the Bay of Bengal. They are just students, and they need to employ their talents for further discovery. And they need, of course, data acquisition from the Bay of Bengal. And I know they are doing occasionally.